video, we'll talk about application tracing. Now, before talking about application tracing, we need to understand why tracing is so important, why we need to do application tracing, and what are the reasons that exist, especially why you need to learn this, why it's so important. If you are a DevOps engineer, want to become an SRE, how will this impact your career? So let us get started and understand everything that's about application tracing, and also like we'll see a sample app using Elastic APM. Now, predominantly in the tech industry, everyone used to ship monoliths. What are these monolith applications? These are a single bundle deployables or executable that ships as a whole. All your code, logic, all the APIs related to the entire project gets shipped in a single jar. Like say, for example, if you are running an e-commerce company like Flipkart.com, so the entire company will ship one executable that becomes the web application for the entire company. So imagine like a website team where everyone does the same thing. So you might be thinking that, oh, that's what we even do today, right? But not exactly the same even today. Today we do something more that we're going to discuss in a minute, but then that puts a lot of pressure onto teams, that puts a lot of other related problems like having interdependencies, issues, etc. Say, for example, some of the trade-offs, let us discuss them, is like if you have everything in one place and you want to update one specific module or a code, and then you need to update, you need to ship other ones as well, where they are completely not updated or changed. Similarly, if you have a bug or an issue, the same story, like you need to fix and patch the entire stuff. So especially in the web world, this is very, very important. Even in the backend world, batch processing world, separation of the processes, etc., not effectively happens in the monolith world. And there are many other related issues that we could discuss. Now, that being said, people have slowly moved to microservice architecture. There are many interesting application patterns in the microservice world as well. You need to definitely take a look at that. So what microservices does is effectively breaks down these modules into individual simple services, like as you see here. Like say, for example, if you take the same e-commerce application, like what does an e-commerce application have? It has a view page, which you will see everything, and it has a search bar, which is a search service. You might be having a checkout service like slash checkout. You have an order service, you have a payment service. So each service is different, and each service might be having a payment as a different database where your card details are probably stored in a high secure place, and then you have your catalog search where all the products are stored in a specific database, and then you might be having your user profiles, which is completely stored in a different database, and it serves as a different UI, etc. So, and imagine that if you need to upgrade, scale up, scale down each one of these, like say if you want to upgrade a specific service, you just deploy this particular thing. Essentially, with the containerization, like with everything becoming a container, you can essentially build these containers, scale up using tools, container orchestration tools like Kubernetes, and then build a robust system that is very easy to manage over a period of time from the application point of view. Now, that being said, microservice architecture doesn't really have any problems. It's not like it doesn't really have any problems or any trade-offs, etc. While there is ease of access or like ease of scalability and everything has happened with microservices, what essentially happens with microservices is like you suddenly see the number of services increase. Like earlier you deploy or ship one jar, but now you are shipping like say a jar probably, and then an executable. Like each of the service can be written in its own programming language. Like each service is a team, and then they ship a specific thing. So all of these kind of like help you to complicate in a way the existing system itself. So this is where systems like words like observability, monitoring come into play, and like you need to monitor your app, you need to find issues, etc. Because if there is a bug in a specific service and the issue comes in a different service altogether, say suppose the user is not able to check out, but the issue is not in the user not being able to check out in the checkout service, because the details are being populated from a user profile service, which gives the address, and the address has some problem, and then like the checkout service is throwing an error. So how do you effectively communicate in between? How do you find such bugs? So that is where your observability or all of these frameworks and tools and tracing helps into play. So what does this tracing especially do? What is it uniquely positioned to do? Now, even though I keep saying tracing, distributed tracing, etc., application performance monitoring is a holistic and very abstract term that encompasses everything. So if I say APM or tracing, don't just think otherwise, it's all the same. Of course, it's a larger term. It has profiling, etc., also to be also included. Say, for example, if I want to understand why does my request to a resource like top/10 took say 8 seconds, like you have sent it at like 17:36 30 seconds, and then you received it at 38 seconds. Why did it take so much amount of time? And if you want to debug that, because it would have gone through several hoops, and like you want to observe how much amount of time a specific method is taking, or in some cases like intermittently in the production, like in the deployment, you are seeing issues like some errors which pop up but you can't reproduce in-house, like in your team inside your company, right? It can only happen in the production, and like you are not able to find it out. So how do you find such thing? Like using APM again, the tracing technology, you could easily improve it. Apart from all of this, then there is a monitoring aspect, like you could profile the application, and you can get how much heap the specific application is taking, like in the case of Java, or like IO and other CPU kind of related details, for other languages based on the language profile. Now remember, in microservice architecture, you could use any programming language. All that it is working is like each microservice is interacting with other microservice. That's where the complexity increases, and then also like that's where the developer productivity gets a hit, and that's why tracing helps you to improve that particular developer productivity. So like I said, APM does a bunch of things, and it helps you to monitor your request response flows, your response time percentiles, like say your latencies, how much time it has taken, you're like whether what is a 99th percentile, what is a 95th percentile, and the request time management. That is one thing. And then moreover that it also helps you to find bugs, like it can handle it can encapsulate all the errors that are occurring in the system, and then show it to you with the code trace, so that you can easily debug and put effects and release it with a specific tag, see how that particular version is performing in the production. So you could do all of that interesting stuff. But why is this so important? Like how I'll explain you with a real world scenario. Like say if you are a developer and you have shipped a code to obviously to your cloud or a data center that you are working, and you have deployed it, and then the user starts interacting with it. The user might be facing errors, the user might be facing warnings, the user might be facing delays in accessing the application due to wide variety of reasons. And then this is the point of a place where you add something like an APM, and then it ships the data to the something like an Elastic Stack or a backend store where all the traces are stored, and the developer can essentially see it and like debug it and understand it and probably put fixes, again continue with the process. So this is kind of like a easy way to understand and debug things. Now you could also ask me, what about logs? I could also see logs of my application and find out. Obviously it is still doable, and you need to do that as well. So several tools help you to do that as well. Now that is what it makes it much interesting. That's where several other things come into play here. Like if you are an SRE, if you are a DevOps person, or wanting to like become this, tracing plays an important role, and you definitely need to have a good idea about it, because to work with the developer, to work with the teams, you always need to have all these three components, which are primarily a basic pillar for observability. We will discuss about observability in the coming video, but then I'm gonna give you a brief idea on how these three would help you do that. Like for example, at any point of time, like say the request that took which we saw recently, like 1736, you called a web API, and then at that point of time, if you would be able to correlate the log line and the metric line, and then also the the data point coming from your traces. Like if you can correlate and find out, you will see, if you could see all three things happening at one point, you can find issues in the application, what's happening, what's the behavior, you can find how the code has reacted, you can also find how the hardware infrastructure is responding to that particular event, like how the metric is, like is there anything problem that has happened from the cloud infrastructure perspective. Now all these three forms this observability triangle, and then helps you to point out, uniquely correlate this particular thing. Now there are more angles to this, like you can add more data points, you could do much more stuff. Now we are not going to discuss that in this video, but we'll simply get over and understand what are the tools that exist in the application tracing point of view. Now there are many open source tools, there are many paid tools as well, there are cloud services. Now in this one I'm going to talk about the open source technologies. Like Open Telemetry is a CNCF project, and it helps you, it is formed with Open Census and Open Tracing. These are the two projects that merged to become Open Telemetry, and again they are trying to take a unique approach to bring in logs, metrics, traces in a vendor agnostic way, and then provide this particular thing. That is one distributed tracing technology that is really popular. And then you also have another CNCF technology. Again, when I say CNCF, I am referring to Cloud Native Computing Foundation, and another CNCF project which is Jaeger, which also is a distributed tracing technology. And then you have Zipkin, which is another third party, or like another distributed tracing tool. And then you obviously have Elastic APM. The interesting part with Elastic APM is like all these three can index data into Elasticsearch. I can use the Elasticsearch as a long-term data store to store all the traces, so that people can correlate it with logs and like and the metrics, or or the application traces, they can correlate that. So that is the important thing here. Now by seeing all of this, Elastic also has come up with its own APM tool, which is and again an open source tool. So we're going to show how like we're going to see how this helps in doing the overall that collecting the traces from the system. So how does the architecture of this particular thing look like? Like if you have multiple services written in multiple programming languages, people do that really, and then you just use these APM agents or packages, and it will ship the traces or data to the APM server, and then like eventually to it gets stored in Elasticsearch, and then you will be able to see it in the Kibana APM app. So that's how we're gonna do as well. I also want at this point of time draw your attention to the project itself. So APM, again, like I keep saying, it's an open source project. We have a GitHub page where you could see all the projects and their contributing .md files. I mean, wherein you can go and look at that and raise issues, raise features, ask questions, probably add support to specific frameworks that you like. Say if you want a specific Python framework that you don't see as a supported in Python agent, you could, that's a good chance for you to contribute and do a great open source contribution. Our teams are actively involved in working with the community, so you could obviously do that. So this is the page that that helps you to interact with that. Just go and check it out. We are going to see a sample app here wherein I explained about building a search engine in the previous video, and then I'm just going to use that point and carry on forward to kind of build something more on it, and also ship traces. Now what I'm trying to do here is we all know that GitHub has its own client, like not just the Git, it has GH client, which was released to do wide variety of things, right? You could create PRs, you could create issues right from the command line, you could work around, push, pull, do a lot of stuff. So this is a site that is there which hosts all the documentation and information about those commands, actually cli.github.com. but if you observe, it doesn't have a search bar. So what I have done is I have used the Elastic App Search Crawler, which we didn't see in the previous video, and then I tried to crawl all the data, and I have built a Flask based app which has a search bar and which shows all the data. And then when I search through it, it searches through this particular the Elastic App search engine, and then it brings me all of that. So and then when I start accessing this app, I'll be able to generate the request response traces, which will be stored in APM server. Eventually I can also see that in the Kibana. Now let us quickly get started in creating this particular application, and I also have all the code in the GitHub already placed. You just need to look at the branch that I am using here. I have a crawl search branch because we are trying to crawl. I have a different sort of a guide for all the other branches, so just refer to the crawl search branch. You could also I'll also put this link in the description as well. Now I'm using Elastic Cloud. I could also deploy this like download and build this on my laptop as well, which I'll show you in a minute once we create once we create a deployment in the Elastic Cloud. Now that being said, again, all our products are free and open. That means you could download, run it on your laptop or run it on any cloud platform. The cloud itself is like runs on any multiple clouds actually. Now there is a tricky thing. Like I guess you might have seen also in the previous video that I have spin up a specific deployment which does kind of like search actually. But here I'm gonna merge both of them and create a one generic deployment just for the case of our app. But in real world, you need to have separate clusters recommended. Like the search cluster is a separate, and your search users need to do something different, and your all the monitoring needs or the observability needs should be separate. It is recommended to do that way because observability will generate more amount of data. Search is kind of stable and it needs faster response, as we all know. So let me quickly create a an enterprise search deployment. I'll choose Google Cloud. I'm choosing Mumbai because that's near to me, and then I'll again name this as code for cause. And instead of clicking on create deployment like the last video, I'm gonna click on the customize bar, and then I'm gonna go down. Like, see, you already have an Elasticsearch instance here, which is available in 2 availability zones. If you have not known availability zones, is just for high availability. It's completely fine. If you don't understand here, then you also have Kibana, and then you also have enterprise search, because we are trying to deploy a search engine actually, right? I'll just add on to an APM deployment as well along with the same deployment. If you are creating this, please do it this way. It is easy for you to understand and get started very easily. So I'm just trying to deploy this, and I'll click create deployment so that it creates that particular type of deployment. So now once I create this deployment, and I'll be able to crawl the data from the specific site, build my code, and also run this Elastic App Search thingy. Okay, so I have all of the stuff that is ready. I just want to explain you how to kind of download this product if you don't want to choose a cloud and you want to host it by yourself. So you could go to elastic.co/downloads, and then you could download the Elasticsearch, you could download the enterprise search and the APM, and then all the instructions are there in the respective pages itself, how to get started. You just need to know that how you need to in Elasticsearch and Kibana, and then you need to start the server with a specific user the IP address, and etc. So yeah, let us quickly go back and see and check out this particular code base, and then get started. So I have a folder named code for cause. Let me clear this one, and then I'm gonna git clone this particular app search Flask app, and it's gonna clone into this repository, and then I'll show you how I want to get this up and running. Okay, I have this, and then I need to change the branch to crawl search because that's on main, and I want to change it to the crawl search where our code resides. And then I want to open it in the Visual Studio Code, which should happen in a minute. Yep. Now let us get started by understanding this particular code base. First of all, what I'm trying to build and what I have. So this is basically, I'm using Flask, Unicorn, and Elastic Enterprise Search Client, Elastic APM, and then PSUtil for getting specific metrics of the of the app. And then I have a Docker file, some other information like templates. When I return the result, I just want to look a bit beautified. Of course, it's not so great, like some of you might be doing great front-end work. And then I have used Spectre.css. It's a open source CSS framework there. And I have this file called config.json. What it has is these details, and I need to fill out these base endpoint, API key, engine name from the search engine. And then I also have this APM related information wherein I have server URL, service name, and secret token, which also is getting generated by the cloud, and then we'll just need to get started with that. So the important and the real deal here is the main.py. Let us get started by understanding that. So this is just importing the Flask, and then I have imported also the respective client libraries, and then you see that I'm trying to load this config.json with this particular command. Like I'm opening the config.json and loading on the information, and thereby I'm initiating the Elastic APM client by using these information that is stored in the config.json. So this is a standard step, like wherein I'm initiating this. I'll also add some code comments for clarity again, so to upgrade this particular code base. So when you get started, you can take this as a reference. And then I also want to create a client for the search engine, so that when I search the search engine, I need to give the information, right? What engine name, what are the way server related details, API key related details. So I'm using this particular thing, and then I have the engine name, and then I get started with the the app root and the basic, and then like I'm having sending the empty query to get all the results in the initially, and then I also have the search related route when I type something and get details. So I'm gonna redirect to results.html. My results are shown again in the specific format. Now this is a standard simple Flask app. Now let us see if our cloud deployment is up and ready, and then we'll start crawling the data and then start building this particular stuff. Okay, the cloud deployment is ready and available. Now just click open enterprise search. It'll show us the standard page wherein you will have to choose between app search and workplace search. When I click on launch app search, it will take me through the onboarding page like the previous video, and I'll just give the name of the search engine is the GH client and continue. And I'll use the web crawler, and I'll click on set up the web crawler, and I'll click on cli.github.com. Now let me show you this page itself, like how does it look like, what I'm trying to explain you here. Like this is the command line for GitHub, and then there is a manual on how to use it, but you see there is no search bar here, like for all these commands. And then I just simply want to add a search bar to this one from a third-party place, and then like showcase it to you all. So I'm just going to click the setup domain, and it will set the domain, and there are some crawl rules which we will discuss in a minute. And then I'll click on start crawl, so that the crawling starts as we continue to speak in between. So basically every website will have some specific crawl rules. Like even every crawler, like search engine crawler, will need to observe that, like you can't crawl some details, you have to crawl some details, etc. So it's called robots.txt, and it's available at the site root, say, and then and it also has a sitemap.xml. So some sites put that out, like you can't crawl xyz, you can crawl like some other things. Like for example, if you have flipkart.com/robots.txt, because they have a lot of content, they might not allow a whole lot of things to be crawled by e-commerce sites or probably other competitors as well. So that is because everything is web, and like they could crawl the HTML pages, strip the prices of the products, etc., etc. So they don't want people to do it, and everyone has to abide to this according to the web standard, etc. So, and sometimes you just want to make sure that the crawl rules are given here as well, so that the crawler doesn't even hit that particular page and then just crawl only the things that are needed. So that is an important thing to observe here. The crawler currently doesn't have that support, maybe, but it's soon coming to directly, without adding any rules, you can simply take out the robot.xml and understand what to be added and what not to be added. But if you still want to exclude some specific sections, you always need to use the crawl rules as well, and there is interesting documentation if you want to understand more about it. Now as we speak, the data is being crawled from the website, and you see that there are more and more stuff here. We'll not get detailed into this particular search related information. We'll just go ahead and pick out the credentials and then paste in our place, because the search engine is ready and we just need to do that. So if you see that I have the API endpoint, which I'll simply paste over here in the config.json. Okay, config.json. I'm just pasting the API endpoint. I also have an API key. Like, see, there is two API keys. One is a search key, one is a private key. Private key has read and write access. Search key only has a search access. Now I'm gonna only pick up the search key because we are not indexing any data. We are just kind of like, you know, using it to search. Now the engine name is gh client. I'm just gonna write gh-client here. So, and then I'm gonna talk about the APM itself. Like, say, click on APM, and in the deployments in the cloud page, I have the endpoint. I'll copy that and I'll paste it here. And then I also have the service name. This can be anything. So I'm just gonna write gh client itself. That is my service name to monitor what is happening. That's the application service name. It's not the engine name. So you could also like write like APM gh client APM. So if you want to identify it differently, and then like, this is a secret token which is needed for you to kind of, you know, send the data to the APM server from a trusted client. So now that the details are configured, let us get started by kind of like going through the code a bit again, and then like understanding what really happens here. So if you see, I have the Elastic APM in like get started, like, you know, all the traces will be sent, and I have given the app here through which the data will be sent to the Elastic, the traces will be sent to the Kibana APM app. And then I also have the app search client where when I search, things will be visible here. Now how do I get started with this application? I'll just start a new terminal, and I'll have to install the requirements of this project, start an environment. So before doing that, I'm using Python 3. So I'm just creating a virtual environment here, and then get started with that. So it might take a bit of time to create this environment wherein we have all of that. So as you could see, I'm creating this stuff. Like let us go env bin and source activate, which activates the you know, the Python -v, and then which shows me it is 3.8.2. Now I will install the requirements file, but we need to be sure that we are in the right command line path where the code exists. Yes, where the requirement file exists. Like, I do pip install requirement.txt. It will install all the requirements that are needed. Okay, now that the installation has happened, let us quickly you know, run the app itself, like directly, and then see whether if it is working or it has some issues to fix. So I'm just going to run python main.py, and then it just simply starts the Flask app on like, you know, localhost I think 5000. The Flask app is running here. Let me get to localhost 5000, and you should see the crawler running and the data already here. Like I said, it is just a view that I have built. The search query hits the particular search engine, and then you get all of these details. Now let me do some sort of a search here. Like, it is going to send the request and get all the details. Like, say if I want to search for issues, and I'll see all the issue related commands. If I want to search about you know, something like PR or pull request, right? Pull request, and I will be able to look at the pull request related information. If I want to look at, I don't know if discussions is a command actually. No, there's no discussion related command. And if I have settings, I could do settings. I'm not sure if that is possible. Yeah, of course, settings there. So likewise, you could do more and more commands, and you could understand what's happening. Like, you know, you could build the search engine. So that we have done that part. But now what's happening in this app? If there is any issue, if there is any error, can I find what's happening in my code itself? So how do I do that? How do I get around and find out? Like, say suppose somebody was trying to access you know, test, and then that API doesn't exist, like, or somebody was accessing, say, hello, like, which they're trying to access the site and like trying to access this particular thing. Whether some of these are captured, I'm not sure. Like, let us quickly get there and like see what is possible and what is not possible. I'm opening Kibana here, or APM, and you'll be obviously like taken to the APM app, and you will see the traces being collected from this app into this particular page. Now always remember that you keep checking this time page. Sometimes like you might have this set to some 1 hour or something, sometimes if you have changed it. So always remember that your time is last 15 minutes. You could also refresh this to update for every 1 second or like 5 seconds or 10 seconds. It automatically refreshes the page. Now this is not it. This is the service, but let us get into it and understand what's happening in your code, or what are the error, if there are any errors, what's happening. So we have 2 endpoints according to the code here. Like if I see, we have 2 endpoints. One is this, one is search endpoint. As usual, you see the post and you get for the search, and you see there's a lot of time to get started with this app. And then the transactions, I think maybe we did very less, but if you are getting more and more transactions, then it might take more time. Now the dependencies is a search engine, and then you see that how much time the search engine is taking, and it is my local system. That's why it's showing all the CPU usage, memory usage, etc, etc, etc. Now this is not it. You will be able to see, this is not a trace, this is just some meta information that we are collecting. Now if you want to take a look at how the trace looks like, this is how the trace looks like. Like say for example, these are the latency distribution of the requests that are coming to the server. Like a specific request, like one transaction took 2200 to 2300 milliseconds. That's like quite a bit of time, right? And you want to find out what's wrong with it. Like it is done on the Chrome browser, obviously you have seen that, and then it is only one trace. 3 minutes ago it happened, and there are some logs, metadata that you could collect. And if I click on this is called the trace, and in the trace is called spans. So if I click on this, and you will see all the information. The important thing that you see is the trace ID, that this particular trace has a trace ID that you could correlate across logs and metrics, etc. And then a transaction ID and all the HTTP request related information. Of course you'll not be able to see specific information, but like some information that you could debug, right? So the service related or the framework related information, because Flask is supported, Django and Flask are supported in Python, and then like you could do that. And then you have the user agent information, etc, etc. If you want to investigate deep, you could go to the logs, metrics. You would also create alerts, which is my favorite thing. So if you want to find out say latency, like if the APIs are taking certain amount of time to kind of give information. Say for example, if every API I have a North Star goal of like should respond within 200 milliseconds, and then there are a bunch of API things that are taking. So I just want to, I could fire out alerts, send pager duty, phone calls to people, and save this alert, etc. This is about the trace, etc. And you could also like go back and see what else is there and what else is available. Like you'd also see the metrics, like what is the CPU uses, system uses. It shows nothing much, but then please remember that like we don't have so many requests coming in, and that's why it's happening. You also can see service map, like I showed in the previous microservice architecture. You might have more microservices, then you want to have a holistic view of how this microservices would look like in a real world deployment. I'll try to put in the demo screenshot here, and then like you could probably go and see how it looks like. So if there are any errors that are generated in the response and request response thing, you'll find those errors calculated here. That is one other thing to look at. So if you want to like find out any transactions or any information that is coming up, you could always use this search request to find out if there are any specific errors. Like say if you want to find out a specific sort of error, you could always do that. http.request.code. I think I kind of like forgot the exact term. http response code, sorry, response dot status code and equals, and then I'll be able to see what are the various codes that are available if I want to find out all the 200s or like all the 400s, all 300s, different types of code. So I could do all of that. I could do search and and filter out my stuff and get all the details. So I could also add machine learning, as you could see, like it's all there. So I don't want to go more deep in it. I want you to explore. I want you to find. If you have any questions, please write in the comments and let me know what you would think. I'll also paste some interesting details like a resource guide, some tutorials to get started, etc. So let me know what you think, and see you in the next video. Thank you.